Hey there, mathletes. Let's go ahead and start talking about section 4.2. So we're moving on from polynomials, and now we're going to be looking at rational functions. So we first got to start with the properties. So let's see what a rational function actually is. So a rational function, it's a function of the form f of x, because it's a function, equals p of x over q of x, where p of x and q of x are polynomials. So you have a polynomial on top and a polynomial underneath. And we just want to make sure that q of x is not equal to the one thing we can never divide by, which was 0. So that's what a polynomial, or a rational function is. Okay, so rational functions, they have something a little bit more unique to them than, say, a polynomial on its own, in that they are going to have some sort of an asymptote involved. So some of them will have a vertical asymptote. So that's when you have x values that make the denominator 0. So what the y values do in that case is they shoot off to infinity or negative infinity as the x values approach that particular number. So again, these are the x values that make the denominator 0. Okay, now some of them will have a horizontal asymptote, and in this case, the y values, it's kind of the reverse. As x shoots off to infinity or negative infinity, the y values are approaching a particular number. And some of them will have an oblique, and that's where instead of a horizontal asymptote, it's a slant or a diagonal. So instead of approaching a particular y value, it's approaching a linear type function. Okay, so example 1, we're just going to find all the vertical asymptotes. We're just going to stick with these for a little bit. All right, so we're just going to go off of what we just said here. It's the x values that make the denominator 0. So if we look at our function from example A, what makes that denominator 0? X equals 3. And that's where you would have a vertical asymptote. In B, x would equal two different values, negative 3 from the first factor in that denominator, and then a positive 4 from the second factor. So you can have more than one vertical asymptote, which should not be too much of a shock. Like if you think of the tangent function, it has infinitely many. So I mean, it can have like one vertical asymptote or a lot of them. Just depends on the function. Okay, example C, what makes that denominator 0? Well, that would be negative 1 and a positive 4. All right, now part B, the second part B, whoops, this one's a little bit different because if you notice, the numerator can factor. And not only can it factor, it's going to do something a little magical in that you can cancel those out. And you're left with x plus 4 over x plus 1. Part C, you could have factored the numerator as well, but nothing would have canceled. So it's not going to affect your vertical asymptotes. But in this case, it does. You had something that canceled out. So the 4 is no longer a vertical asymptote. But the negative 1, since it's still in there, that still makes the denominator 0. That's still an asymptote. All right, and this last one, example E, nothing you could do to that denominator wouldn't ever make it 0. So in this case, there are no vertical asymptotes. So they don't have to have one. A lot of them that we're going to see in this section, they do, but not all of them. Okay. Well, let's go ahead and stop the video here, and in the next one we'll talk about the horizontal and the oblique asymptotes.